Hi everyone, it's Miss J. As I mentioned yesterday, I am in the building, but I am not in class. So here is a quick, brief summary of what we had learned yesterday by means of a warm-up. In this video, we'll talk about the big ideas from yesterday's class. But before we do that, let's just take a quick rundown of the expectations for today. In a moment, or the sub may have already passed it out, there is a worksheet that we will work on together during this video. Let me see, how many questions is it? It is 3 questions. After that, the video will end, and you will have the rest of class to work on the workshop that was done yesterday, or started yesterday. We did a couple of examples all the way through, and then we did the setups for a bunch. It was also last night's homework to do as much of it as possible. So that being said, it is definitely, absolutely, 100% due at the end of class. Your workshop needs to be in the substitute's hands by the bell to earn credit. So please do not leave without turning it in. Tonight's homework is a worksheet which will be passed out by the substitute at the end of class or when you have turned in a completed workshop. But do not turn the workshop in blank. If I see that it was turned in blank, it's going to not be a good thing because there's no reason for it to be blank if you did your homework and you used your class time well. So it may be that you pick it up at the end of class. That's perfectly fine. No problem at all. So let's do our examples for this morning. This is the handout. This is what it looks like. So at this time, the substitute, please pass this out if you have not already. 3 questions. One is about temperature, there's a piggy bank, and this is about motion detectors. Go ahead and pause the video if needed to pass that out. And we'll start with number 1. At the top, we have a nice little notes box, which helps us remember what we talked about at the end of yesterday's class, or not at the end, at the beginning, about the difference between a rate and a unit rate. So an example of a unit rate is $8 per hour because, as we talked about, per hour really means per 1 hour. Now technically, if you earn $8 in an hour, it means you earn $16 in 2 hours. They're both rates. This is a rate. This is a unit rate. Another example, in a distance time function, the slope, you could say the rate is you move 3 meters in 2 seconds. That is a rate. It is not a unit rate. For it to be a unit rate, I need to divide. So 3 divided by 2 is 1.5 meters per second. And again, when you say per second, what you're really saying is per 1 second. That's what a unit rate is all about. So we have 3 examples. Let's look at our first one. At 4 a.m., the temperature was 38 degrees Fahrenheit. By 11 a.m., the temperature had risen to 60 degrees Fahrenheit. Find the average rate of change or slope in degrees per hour. So let's first start by defining variables. That will always be our first step. We can use X and Y. We are looking for measurable quantities, 2 measurable things. So when I read this, I see it's about time. Time is measurable. Time is always my IV, my X value, my independent variable. So time is X measured in hours. My Y value is temperature. In degrees Fahrenheit. Now, I see 4 a.m., 11 a.m. I want to set a 0 hour. So last class, yesterday, we practiced establishing a 0 year. We also looked at a table where time was connected to a 0 time. I think it was noon was hour 0. So here, our hour 0 is going to be 4 a.m. So we'll define this as time in hours since, or after, whatever word you like better, 4 a.m. We have our variables. Our next step is to get 2 ordered pairs. So my first ordered pair is going to be 0, 38, because at 4 a.m., my 0 year, the temperature is 38 degrees. Now I look for my next ordered pair. says by 11 a.m. Well, we need to figure out how many hours after 4 a.m. is 11 a.m. Some may count, some may choose to use a calculator. Whichever gets you to the value is fine. We can use a calculator if we're not sure what 11 minus 4 is. What is 11 minus 4? Pretend like I'm there. I'll wait for somebody to say it. 7. So my next ordered pair is going to be 7, comma, at 11 a.m., temperature 60 degrees. I now have my 2 ordered pairs. Just going to move it up a little bit. So let's review. I've defined my variables. I now have my ordered pairs. I am now ready to do my calculations. Change in y divided by change in x equals, we're going to subtract our y values. We could do 38 minus 60 or 60 minus 38. I choose to do 38 minus 60. If you choose to do 60 minus 38, make sure you follow the same order. We should get the same answer. Because I did 38 minus 60, in the denominator, I need to make sure I do 0 minus 7. So if you haven't taken out your calculator yet, do that now, please. Do the math with me. So we're doing 38 minus 60, which gets me negative 22. 0 minus 7 is a negative 7. We divide 22 divided by 7 and get 3, a positive 3.142, or let's see, rounded 143. We will be rounding to 3 decimal places always in preparation for SAT practice. The SAT, we're going to go to 3 places, so it's a good habit to start now. Let's trace back. My numerator is all about y. So to start off my label, I look at y. Y is degree Fahrenheit. So 3.143 degrees Fahrenheit per, let's see, in the denominator, I trace it back. X is in the denominator. X is hours. I now have my unit rate. A nice little sentence would be something like, temperature increased at an average rate of 3.14, if you choose to round it, you could, or 3.143 degrees Fahrenheit per hour. This sentence tells me you understand what you found as your answer. So a nice little sentence wraps up the question. Number 2, Sarah started out with $50 in her piggy bank. Let's scroll up in case somebody's still writing. Sarah started out with $50 in her piggy bank. Every week, she deposited the same amount of money in the bank. After 7 weeks, she had $67.50. Find the average rate of change or slope in dollars per week. Let's define our variables. We're looking for 2 measurable quantities. So I know that this is about money and weeks. So time will be X, number of weeks, or time, and in parentheses put weeks. X is number of weeks. Once I know how many weeks have gone by, I know her total savings. How much she has in the bank. Now that I have defined my variables, it's time to get some ordered pairs. Says Sarah started out with $50 in the bank. Think to yourself, what week would be associated with the start? It's not going to be 1, because it would tell me at the end of the first week she had $50. That would be 1, 50. The moment she opened the account, she deposited that $50 as the start of her account. So that will be 0, 50. Then I know after 7 weeks, she now has $67.50 in the bank. I've defined my variables. I have my ordered pairs. I am now ready to do my math. So I've got change in y divided by the change in x. We're going to subtract our y values first. So 67.50 minus 50. And if I choose that order, I need to do the same in the denominator. So that would be 7 minus 0. 67, 50 minus 50 is, try it yourself first, we should be getting 17.5 divided by 7 equals 2.5. This is only half of an answer. Now we need to get our units. So if I trace back, in the numerator, it's all about Y. Y is her savings. So this will be dollars per. If I trace my denominator back, trace it back, back, X is in the denominator, X is weeks. Our sentence, Sarah deposited an average rate of $2.50 per week. And we're done. Last but not least, Mr. Peel started 7 meters away from the motion detector. So that's why here I have 0.7. Because my Y values is the distance away from the meter. So he is starting out 7 meters away from the detector. 2 seconds later, he's 3 meters away. Here's the graph of his motion. Find the rate of change or slope in meters per second. As soon as I have a table or a graph, it's nice because I know that this is X and this is Y. So X equals time in seconds. We're pulling that right from the graph. And Y equals distance in meters. He started 7 meters away. So we have established that as the ordered pair 0.7. From the scenario here, I know that 2 seconds later, he's 3 meters away. Now, technically, if you just wanted to use ordered pairs from the scenario, these could be my 2 ordered pairs. But recognize that I also am provided a graph. So I could have used 1.5. I could have used 2.3. Oh, look, we are using 2.3. Or I could have used 3.1. I would stay away from this one because I'm not really sure. That could technically look like a 3.5, but maybe it's 3.4. Maybe it's 3.48. You're not exactly sure. But for the purpose of pulling information out of what's written, we will use these 2 ordered pairs. We're now ready to do our math. So change in Y divided by change in X. We'll do 3 minus 7 divided by 2 minus 0. That's a negative 4 divided by 2. I get negative 2. Now let's get our units. I trace back. Y is in the numerator. Y is measured in meters. So that is meters per. I trace back the denominator. I have X values. X is seconds. Let's talk about why it makes sense that this is a negative rate. Think again about what this entire scenario is about. He is starting away from the motion detector and is walking where? Is he walking farther away or is he walking towards? Well, if I look at his distance, he's closing in on it, right? He's walking towards the detector. So for our sentence, we'll write Mr. Peel is approaching, he's getting closer to it, closing the distance, approaching the motion detector at a rate of 2 meters per second. And we're done. So this wraps up our notes. You'll notice there is no back to this worksheet. but this is a really nice summary of all of the practice we did yesterday. Now, in yesterday's notes, we had other questions that had some graphs, it had some intervals in there. So please pay attention to those notes we took yesterday. If you were absent, sit with a friend and catch up on those setups. So the rest of class, you have to finish the workshop from yesterday. If you need an extra copy, look in the level 2 folders. It's the only document in the middle row. Or look at a neighbor's and figure out what you need. At the end of class, you are turning in that workshop to the substitute, and this is what tonight's homework looks like. And I will zoom out so you can see the whole page. This is tonight's homework, 5 questions. Okay? This you will pick up at the end of class. And it will be due first thing, what's today? Today's Tuesday, recording the video. No, today's Wednesday. No. You're watching this tomorrow, which is Thursday. So this will be due first thing Friday morning. Due Friday at the start of class. All right? Great job, guys. Please send me any questions on Remind. I will be back in my room after 11 o'clock. So you can stop by F, G, or H and check in with me. Have a great day, guys.